Use the Taylor theorem for the function u of x and t equals t e power xt with the step size delta x. T is held constant. At this question, we should suppose that t is constant. T is constant and x is a variable, and delta x is my step size. It is the solution of exercise 1, question 1. You should apply the Taylor theorem for the u that u is of x and t. U of x0 plus delta x and t equals u of x0 and t plus delta x, ux at x0 and t plus delta x over 2 factorial uxx of x0 and t plus delta x power 3 over 3 factorial uxxx, the third derivative of u respect x of x0 and t plus 2 delta x n over n factorial u n x means the nth derivative of u respect x of x0 and t plus delta x power n plus 1. Please attention to this expression. When we write O delta x power n plus 1, please be quiet. Can you hear me? Can you hear me, Miss Zaina?
بله صداتون داریم خانم. متوجه شدیم خانم.
Okay. When we write O of delta x power n plus 1, the highest derivative we should compute is the nth derivative of u respect x. Un respect x plus O of delta x power n plus 1. At this question, we have u of x and t equals to t exponential or xt or t e power xt. The first derivative of u respect x is t2 e xt. The second derivative of u respect x is t3 e power xt. The third derivative of u respect x or uxxx equals t power 4 e power xt. And thus we have the nth derivative of u respect x is t power n plus 1 e power xt. Why? If we attention to the structure of the derivative, we can see that when we have the first derivative, the power of t is 2. When we have second derivative, the power of t is 3. The power of t is 1 more than the derivative of u. When we have uxx, the third derivative of u, we have t4. And then when we have nth u of respect x, the nth derivative of u respect x, we should have t power n plus 1 dot e power xt. It is okay?
Okay,
You
okay,
understand? Okay.
okay.
Then we have this u and their derivatives replace in the u x0 plus delta x and t at the first expression at this page. We replace the u and ux and uxx, uxxx, un of x in the first expression at this page. And we have ux0 plus delta x and t equals, instead of ux0 and t, we write t e power xt and replace x0 instead of x, plus delta x and we write delta x. We have u respect x at x0 and t. U respect x is t2 e power xt. At this expression, we put x0 plus x, and we have t2 e power x0 t. For the third expression, we have delta x2 over 2 factorial uxx at x0 and t. And we have delta x2 over 2 factorial. And we put t3 ext instead of uxx, and we put x0 instead of x, and we have t3 e power x0 t plus delta x3 over 3 factorial uxxx of x0 and t. For the third derivative of u respect x, for this u, we have uxxx equals t4 e power xt, and we put t4 e x0 t, and we replace x0 instead of x, plus 2 until delta x n over n factorial u n's derivative of u respect x of x0 and t. And we should write delta xn over n factorial, and we write the t power n plus 1 e power x0 t instead of the nth derivative of u respect x, and we put x0 instead of x, and plus O of delta x power n plus 1. O of delta x power n plus 1 is the truncation error. The order of the error is n plus 1. The power of delta x is the order of the truncating error. It's okay?
Okay.
Are you understand this part of the question 1?
No, no.
Okay. We go to the question 1, part B. At this part, we want to apply Taylor's theorem for u of x and t respect t. Means I suppose that x is constant and t is a variable, and we apply the delta t for the change in t0. Based on the Taylor's theorem, we have u of x and t0 plus delta t. What is the delta t? What is the delta t? Delta t is the step size for t.
Yes, yes.
Delta t is the step size for t, and we want to apply the Taylor's theorem for the u is t e x t. X is a constant and t is a variable. Based on the Taylor's theorem, we have u of x and t0 plus delta t equals u of x and t0 plus delta t, u respect t, not u respect x, because at this part, the constant x and t is variable. U respect t of x and t0, not x0. X is constant and t is variable. U respect t of x and t0 plus step size power 2 or delta t2 over 2 factorial utt, the second derivative of u respect t at x and t0 plus delta t3 over 3 factorial u t, the third derivative of u respect t at x and t0 plus delta t4 over 4 factorial u for t means the fourth derivative of u respect t at x and t0 plus 2 plus delta t power n over n factorial nth derivative of u respect t or un t or un respect t at x and t0. Because we write these terms until the n derivative of u, the last term is O of delta t power n plus 1. When we write O delta t power n plus 1, the nth derivative of u respect t should be computed. Un O delta t power n plus 1. This is the this is the general form of Taylor's theorem. Let me to draw the rectangular under this formulation. It is the general form of Taylor's theorem respect t. At this question, again, we have u of x and t is t-e-x-t. The first derivative of u respect t is xt e power xt plus e power xt. Is it clear for you? The derivative of u respect t is clear by product rule. قاعده ضرب. Okay. Are you you should compute the nth derivative of your respective nth derivative. تا مشتق مرتبه n باید محاسبه بشه. You should repeat the derivative until the end, order of n for derivative. This is the first derivative, xt e power xt plus e power xt. The second derivative, or utt, equals x2t ext plus 2x e power xt by using a product rule for the derivative. Please pay attention. Utt is the second derivative and we have x2. T e power xt plus 2x e power xt. When we compute the third derivative of u respect t, or uttt, we have the solution is x3t ext plus 3x2 ext. We have the third derivative and the x power t. For first derivative, we have x power 1. For two derivative, we have x power 2. For three derivative, we have x power 3. And so, for fourth derivative, we have x power 4. Then t e power xt plus 4x3 e power xt. The rule of nth derivative is clear until now. Please attention again. First derivative, I repeat again. First derivative, xt e power xt plus ext. Utt, the second derivative, x2 t e power xt. Utt, the third derivative, x3 t e power xt. For the fourth derivative of u respect t is x4 t e power xt. And then for the nth derivative of u, we have xnt e power xt. Okay? The last term in the derivative is, for the first derivative, we have e power xt. For the second derivative, we have the derivative of x2 is 2x e power xt. The third derivative, we have 3x2. 3x2 is the derivative of x3 respect x.
Yes,
3x ext. For the second term, we have 4x3 e power xt. And then for the nth derivative of u respect t, we have for the second term nx power n. And it is the rule for the nth derivative of u respect t. Okay?
Okay, very good.
At u t u t t u t t t u 40 and it's sufficient. We this use to the general formulation of Taylor theorem at the beginning of this page. We put TEXT instead of UX T0, and we have U of X and T0 plus delta T is T0 e power X T0. We should put T0 instead of T. Please pay attention. Instead of T, we should put T0, not T. In the Taylor theorem, we should put T0 instead of T. For the second term, we have delta T and we write delta T. And for UT and X and T0, we write X T0 e power X T0 plus e power X T0. We should this term with T0 instead of T. For the third expression, we have delta T2 over 2 factorial, and we write delta T2 over 2 factorial. And the UTT of X and T0, we have X dot T, X2T e power XT plus 2X e power XT. And we should this derivative and plus and put T0 instead of T, and we have X2 T0 e power X T0 plus 2X e power X T0. For the next term, we have delta T3 over 3 factorial, and we should write delta T3 over 3 factorial. UTTT at X and T0. For UTTT, we have X3T EXT plus 3X2EXT. We should write this sentence, and we should put T0 instead of T, and we will have X3 T0 e power X T0 plus 3x2 e power X T0 EX T0 plus 2 until delta Tn over n factorial, and we should have the nth derivative of u respect t, or xn t e power xt plus nx power n minus 1 e power xt. We should write these terms, and we should put the T0 instead of T. And the last term is the truncation error, and we have O of delta T power n plus 1. And it is the solution of question 1, part B. Are you understand this part?
Yes.
Is it okay?
Okay.
Is it hard or easy? It's very easy, yes? Not hard.
Yes.
Okay. We go to exercise 2. For the question 2, at part A, we have use the Taylor theorem for function u of x and t with the step size delta t, x is held constant. And for part B, we have consider the second order truncation error of delta T2 for the Taylor formula, and then obtain a finite difference approximation for the first order derivative of U respect T. The goal of this question is to approximate ut of xt by the first order derivative. For part A, similar to the question 1, we write and apply the Taylor's theorem for u of x and t respect t, and we have it is the repetition of the question 1. U of x and t0 plus delta t equals u of x and t0 plus delta t, ut of x and t0 plus delta t2 over 2 factorial, utt of x and t0 plus 2 delta t n minus 1 over n minus 1 factorial, u n minus 1 respect t of x and t0 plus O of delta tn. At this example, we write the O of delta tn, and I should write the last derivative, the order of n minus 1. The order of last derivative should be 1 smaller than the order of truncating error. Is it okay? O of delta tn, and I write u n minus 1. When we write delta t power n plus 1, we should write u n respect t. Is it okay?
خب آقا یعنی فرق این سوال اول و سوال دوم فرقش اینه که جای x و t رو عوض میکنیم، نه؟
سال اولم برای کی داشتیم؟ اینم سال اوله. ببینید سال اول قسمت تو همینه دیگه. برای تیه دیگه. این سال 1 قسمت 2 مگه برای تی ننوشتیم اینو؟
بله منظورم اینه که الان سوال دوم شما شروع کردیم.
بله. سال دوم هم
سوال اول جای x و t نوت رو عوض کردیم.
نه یکیه. سال دوم قسمت اول همین سال اوله، هیچ فرقی نمیکنه.
خب سال دوم
یعنی سال اول قسمت دوم هستش دیگه، درسته؟ اینم سال دوم هست. فرقی با هم دیگه نداره.
پس چرا شد n منهای 1؟
فرقی نداره. نگاه کن، من اینو شما میتونید به جای این n چی بذار؟ n به اضافه 1 بذار، همون قبلیه میشه.
بله. خب منم میگم چرا n منهای 1 شد توانش؟
باید همیشه توان یکی کمتر از مرتبه خطا باشه.
بله.
این مرتبه خطا من تا n نوشتم، باید تا مشتق مرتبه n منهای 1 بنویسم. مثلا در مثال
اون یکی زیادتر. بله.
n به اضافه 1 نوشتم، اینجا تو مشتق مرتبه n حساب کردم.
بله.
میس سیما حسن، are you understand? This is the Taylor theorem. Are you understand the question 1? Yes. The question 2 is similar to question 1 part B. Ux t0 plus delta t and the right hand is the similar to بذارید من اینو کوچیکش کنم. Please attention. Question 1 part B is the question 2. They are same, they are similar, they are equal, they are same. Please attention. Ux t0 plus delta t, ux t0 plus delta t, ux t0, ux t0, delta t u t x and t0, delta t u t x and t0, delta t2 over 2 factor u t t, then we have delta t2 over 2 factor u t t. They are similar, they are same. Okay? In the 1 part B, I write O of delta t power n plus 1. And the latest derivative is the order of n. But in this question, at question 2, I write O of delta tn, and I should write the n minus 1 derivative of u. 1 smaller than the order of truncating error. Yes, delta t power n, and we have un minus 1. Delta t power n plus 1, and we have un. The order of partial derivative is 1 smaller than the order of truncating error. Okay? Are you understand? Very good.
Yes.
I'm increase the zoom. Okay. In question 2, part B, consider the second order truncation error O delta t power 2. Okay? And we should truncate, stop, and 2 term. After 2 term, we should stop. Ux t0 plus delta t, when truncating error is O of delta t2, we should use only the first derivative, not bigger than first derivative, not 2 derivative, not third derivative. We should only use the first derivative of u, because O of delta t2, the power of delta t is 2, and we should write the derivative of u only until order 1. Is it okay?
Okay, yes.
Delta tn derivative is n minus 1. Delta t2, the derivative until first derivative. Then we have u of x and t0 plus delta t equals u of x and t0 plus delta t, utx and t0 plus O of delta t2. Okay? Then we move ux t0 from right to left, and we have u of x and t0 plus delta t minus u of x and t0 equals 2 delta t utx and t0 plus O of delta t2. Our goal is to compute u respect t at x and t0. We have to compute utx and t0, and then we should divide sides by delta t. When we divide the sides by delta t, we have ux and t0 plus delta t minus u of x and t0 over delta t is equal utx and t0 plus delta of delta t2 over delta t. We divide the sides by delta x. طرفین رو بر delta x تقسیم کردیم. We divide the sides by delta x. And then we have u t of x and t0 is equal to this fraction, or the u of x and t0 plus delta t minus u of x and t0 over delta t minus o of delta t, because we move this term is o of delta t, okay? And we move o of delta t from right to the left, and we have minus o of delta t. This formula says when we have ut of x and t0, you can use this expression for u of u respect t. If we drop the truncating error, we have an approximation for ut at x and t0, not only for ut at x and t0, but also for every point, for each point xi and tj. We have used this formula, and we have ut, we write xi instead of x and tj instead of t0, and we have ut of xi and tj equal to u of xi and tj plus delta t minus u of xi and tj over delta t minus o of delta t. It is it should be extra. It's extra. Okay, by dropping o of delta t, we get an approximation formula. Ut at xi and tj is approximate by u of xi and tj plus delta t minus u of xi and tj over delta t. At the previous session, we have said to you, if this point have the I and j for indexes, the next point at the same row have the I plus 1 and j. At the previous point have the I minus 1 and j minus I minus 1 and j as indexes. And the next point at the next row we have I and j plus 1. Is it okay? These indexes are okay for you? Are you understand these indexes? I minus 1 and j, I and j, I plus 1 and j, and this point is I and j plus 1. T is change, but x is constant. I don't change, but j increase from j to j plus 1. Okay?
Okay.
When we
خانم آقای چجوری سوال دوم مطلبش چیه اصلا از اول؟ چرا ما مثلا
میخوایم
دو
یک
مرحله.
دیگه تیلور نیست، میخوایم یک فرمول برای مشتق به دست بیاریم الان دیگه.
منظورم اینه که مثلا خودمون الان خودمون مشتق از همون یه فرمول جدید میخوایم بسازیم، نه؟
دیگه اینا فرمول واقعی مشتق واقعی نیستن، اپروکسیمیشن هستن، یک اپروکسیمیت هستن برای مشتقات. میخوایم یک سری فرمول ها به دست بیاریم که نخوایم مشتق رو حساب کنیم، میخوایم از روی یو ها مشتق رو حساب کنیم. ببین دیگه تو این فرمول ما مشتق نداریم، داریم از روی چی مشتق رو حساب میکنیم؟ از روی یو ها داریم مشتق رو حساب میکنیم، درسته؟ نمیریم سراغ مشتق گیری، میخوایم مشتق رو به کمک
یعنی
فرمول
مستقیم دیگه اون از اون فرمول اولی استفاده نکنیم مال تایلر.
حالا ما کلی میگیم وقتی میخوایم از یک یوی که نمیدونیم چی هستش، ممکنه هر فرمولی داشته باشه، خب دیگه نمیریم قواعد مشتق گیری، قاعده ضرب، قاعده تقسیم، از ساین، از کوساین، از اینها مشتق بگیریم. میایم از خود یوشون استفاده میگیریم، دیگه سراغ مشتق گیری نمیریم چون مشتقات ممکنه ما نداشته باشیم.
متوجه شدم خانم باقری. فقط من منظورم اینه که مثلا دیگه از قانون اول تایلر استفاده نمی‌کنیم، از همین از این فرمول آخری استفاده کنیم، چون مثلا به قول خودتون ما مثلا نمیدونیم مشتقشون یا مشتقشون سخت باشه، از این استفاده می‌کنیم.
بله. یعنی ما اگه دقت کنید این همون قضیه تیلور هست دیگه، مگه این به غیر از تیلوره؟ این همین قضیه تیلور بود دیگه. نگاه کنید صفحه قبل، این قضیه تیلور بود، اومدم از تیلور مشتق اول به دست آوردم.
بله.
خب این میشه یک فرمول برای مشتق. اینا خیلی شما کم جلو ببینید که مثلا جلوتر برید، حتی تو درس‌های بعدی وقتی میگیم مثلا قاعده فیکسه، چه فرمول رول اپروکسیمیشن بیوتی اول از تیلور یک فرمول
انتبهتي سيما شو يقول؟ سيما انتم صاخنه وبالك مو يمها، وانا همتين بالسياره وطالعه هم بالي مو يمها. المهم قلت لها قلت انت قلت لها منين اعرف انا ابدي بهذا القانون؟ فايش قلت لها زين هذا ليش؟ قالت بما ان مثلا اكو دوال مثلا صعب الاشتقاق مالته، مثلا اذا ساينات، اذا كوساين، اذا اكسبونينشال، زين فاني ايش راح اسوي؟ راح اشتق، بعد ما راح اشتق راح اشتق الداله حتى استفاد من الواي مالتها بدون اشتقاق. راح اطلع قانون جديد اللي ما بيه مشتقه. شوفوا هسه هذا اخر واحد ما بيه مشتقه يو للاكس، عرفتي؟
I repeat again, Miss Sima. This is Miss Sima. I will repeat again. It is essential for this lesson. It is the Taylor's theorem. Okay. Okay, or yes or no? It is a Taylor's theorem. Okay. At this formula, we have U respect T. It is a equilibrium. یک معادله هست. We solve this equation and find UT. Very easy. When we have A equal to B plus CX. When I move B from left to right and then divide by C, okay, and find X. It is similar. Its UT is the same as X at the above equation. We should find U respect T from this formula. Yes. And we move UT from right to left and then divide over by delta T and find UT. We should find UT and the end expression I find UT based on u. We should not compute derivative. We compute u respect t based on u. When we have u, we can compute u respect t, not by derivative formulation. We don't use formulation for derivative of u. For example, product rule or divided rule or e beta or e power u. No, only by using u we can compute u respect t. Okay, we can compute u respect t at x and t0 by using u at the point x and t0 plus delta t and x and t0.
Yes.
Okay, we put instead of x, xi, and instead of t0, tj, and we have u respect derivative of u respect t equals u of xi and tj plus delta t minus u of xi and tj over delta t minus o of delta t is the order of truncating error of the formulation for u respect t.
سيما يعني المشتقة يولد في باعهم عشان خان بغل. شوفي المشتقة اللي يولد تي المشتقة الأولى راح أحصلها من الدالة بعد ما يحتاج أشتق المشتقة أحصلها من هذا القانون. عرفتي؟ أي دالة كانت بس احنا بصورة عامة بدنا نحكي أي دالة كانت المشتقة الأولى مالتها تقريبا وشوفي كاتبة تقريب اللي هذا اللي عندنا قبالنا خان باقر يعني على مشتقة اولشو از همین فرمول استفاده میکنیم هر چیز فانکشنی باشه نه
هر فانکشن برای خود فانکشن یو رو استفاده میکنیم مشتق اول در هر نقاط شبکه‌مون حسابش
الان متوجه شدیم بعد این چیز او دلتا تی کجا رفت
اون حذفش میکنیم این میشه مرتبه خطا میگیم خطای این فرمول خطای محاسبه مشتق ما از بخلاف مشتق واقعی نیست دیگه خطا داره تقریبه مرتبه خطاش مرتبه 1
اوکی تا اونجا مساوی بود وقتی هم خطا رو برداشتیم میشه تقریب
چون خطا رو داریم حذفش میکنیم تقریب زده میشه با چه مرتبه خطایی چون اوی دلتا 1 هست توان دلتا تی 1 میگیم خطای مرتبه 1 داریم فرست اوردر داریم اوکی and when consider the point I and J at this row اینو جلسه قبل گفتم خانم زینب طالب وقتی ما توی این سطح هستیم x همون ثابته یعنی t همون ثابته I همون داره تغییر میکنه t is constant and x in a variable when plus delta x we should have I plus 1 and j when we minus delta x we go to x we go to the point with I minus 1 and j and when we plus delta t the point is the index of this point is I and j plus 1 okay and the final formula is ut at xi and tj approximate by ui and j plus 1 minus ui and j over delta t. It is it is the point with the indexes I and j plus 1. It is the point with the indexes I and j. We should compute u respect t at this point, okay? And we go above and we have I and j plus 1. Because this is a forward formula. This is a forward because we have compute ut at xi and tj and we use u at xi and tj plus 1. And we have u with the indexes I and j plus 1 minus u of with the index I and j over delta t. It is the first order. Why the first order? Why the first order? Because dropping the o of delta t power 1, this formula is the first order, okay? This formula is the first order because we drop O of delta t. We delete O of delta t and this formula is the first order. Why forward? Why this formula is forward? Why this formula is forward? Why it is not backward? We go above. Attention, we should go above. ما باید بالا بریم. نقطه بعدی. We use the next point, okay? Not before point. We use the next point. I am at I and j and use I and j plus 1. I use the next point. چون من نقطه بعدی رو استفاده می کنم forward رو به جلو هست، به عقب بر نمیگرده. This formula is the forward formula because we use the next point, not before point. I use the next point for this formula and then we call this formula is the forward. Okay, it's forward. Approximation to ut at xi and tj. Okay, it's the first formula for ut. We will familiar with the three type of approximation for the first derivative of u respective. Forward approximation, backward approximation, and central approximation. This is forward approximation. Okay? Please study this exercise and you have any question you can ask. Please study this exercise, these questions, and their problem you can ask. I'm quiet and you please you study. Okay. Do you have any question? Yes or no? Do you have any question? Okay. I want to put this exercise for you for next class, and I prefer to solve this question in the class. I want to solve you this question after class, and then I try to solve with the other solve this question in the class. Suppose this is exercise for this time. Suppose that ux and t equals x2 plus t2. X is in the interval 0 until 1, and t is the interval 0 until 1. Okay? X is from 0 to 1, and t is from 0 to 1. Okay? Consider delta x equal to 0.25 and delta t equals to 0.5. Then, first, determine the coordinate of grid points. Please determine the coordinate of grid points by using delta x equals 0.25 and delta t equals 0.5. First, determine the coordinate of grid points. Please solve the part A. Yes. And then send to me via WhatsApp. Only part A. Only determine the coordinate of grid points. یعنی فقط مختصات نقاط شبکه رو پیدا کنید. Yes.
Yes.
Please say to me, x0 equals what? Equals 0. Because we start from 0 for x, okay? And then x1 equals what? Step size for x is 0.25, okay? And then 0 plus 0.25 x 0.25, okay? Because the step size x is 0.25.
0.
What about x2? x2 equals 0.5, okay?
50, yes.
And x3 equals
25, yes.
25. And finally, x4
Yes.
equals what? 1. Points can you see at this problem for x? How many points for x? 5. x0 is 1, 2, 3, 4, 5. Okay? We have 5 points for x. Okay? Please be quiet. One of is busy. Miss Zainab Saleh. Miss Zainab Saleh صدای من رو داری؟ My dears, can you private, please send me private.
درسته؟ نه.
My dears, please attention to me. Please attention to me. How many points can you see for x? How many points can you see for x? How many points? x0, x1, x2, x3, x4. How many points? 5. We have 5 points for x. Okay. Why we have 5 points? Because the distance between 0 to 1 is 1. Okay. And 1 minus 0 over delta x 0.25 is 4. Okay, 4 in the end index x4, and when we divided the distance of intervals 0 to 1 by delta x, we have 0. But the number of point is n plus 1. And 4 plus 1 is 5. And the number of point is 1 more than the index of x. Okay?
Okay.
And then for t. T0 equals to t is start from 0 to 1. T0 equals 0. And the next point for T1 equals to 0.25 or 0.5. Which of them? The step size for T is 0.1, and then T1 is 0.5. Because the step size for T and the step size for X is not the same, is not equal. Okay, the step size for T is delta T and equals 0.5, and the step size for X is delta X equals 0.25, and then T1 equals 0.1. The next point for T is T2, okay? And what T2? What is T2? What is T2? 1. I continue, yes or no?
Yes, yes.
Do we have T3 or no?
No, no.
No, because the 1 is the end of interval for T, okay? 1 is the end of interval. T start from 0 to 1. 1 is the end of T, and we don't have a T3. And the end point of T is T2 and is equal to 1. Okay? It's okay.
Okay, okay.
And for the coordinate, we have, this is the axis for X, and I zoom in this picture for to see better. Okay, this 0 is x0. This point is x1. This point is x2. This point is x3. And the next point is x4. Okay? And for the T0 is T0. 0.5 is T1, and the end of T is T2. Okay? For this point, the first 0 and 0, okay? This point is the coordinate for this point is 0 and 0, and we have P x0 and t0, because this point is the interaction of x0 and t0. And for this point, we have x0 and t0. What about this point? The x for this point is x1, and the t for this point as t0. And the coordinate of this point is for x 0.25 and for t is 0. Is it okay until now? Okay? Yes.
Yes, yes, yes.
What about this point? For this point, the x is x2, and the t for this point and still is a t0. And the coordinate for this point for x is 0.5 and for t is 0. And then we have p x2 and t0 equals 0.5 and 0. And the fourth and the next point we have x3, and until we have t0. For this point, we have x3 and t0, and the coordinate for this point is for x 0.75 and for t until we have a 0. Okay, and for the next point, we have for x x4, and for t we have t0. And the coordinate for this point, for x4 we have 1, and for t0 we have 0. And for this point p, x4 and t0 equals to 1 and 0. Okay?
Okay.
Finally, how many points we have on this domain? How many points at this domain we have? How many points can you see for this
15?
domain?
Domain.
You should sum x and t together.
0 and 1.
How many points have you at this domain?
How many يعني قد العدد 15 يعني قد
This is the domain of problem.
15
At this domain, how many points can you see? 15 points. Okay, 15 points. Okay, these 15 points are our grid points. Okay, these are our grid points. We have 15 grid points. Is it okay?
Yes.
Okay.
Okay.
By using delta x and delta t, by using delta x and delta t, we discrete the domain of problem. This square is the domain of problem. This red square. این مربع قرمز دامنه مسئله ما هست. مسئله اصلی ما کل همه نقاط این مربع جز دامنه اصلی مسئله ما هست. ولی ما به کمک دلتا ایکس و دلتا تی مسئله‌مون رو گسستش کردیم. یعنی دیگه ما در همه جا دنبال حالا یو در مشتقات یو نیستیم. فقط تو همین 15 نقطه میتونیم مشتق حساب کنیم. اینجا نمیتونم مشتق حساب کنم. اینجا نمیتونم. فقط تو همین 15 نقطه شبکه میتونم مشتق حساب کنم. ولی مسئله اصلی ما پیوسته است. رو کل این مربع باید مسئله در واقع یو رو داشته باشیم. درسته؟ ولی برای حالا مشتقات ما وقتی گسستش میکنیم تا این 15 نقطه میتونیم مشتق رو حساب کنیم. اینو لطفاً خانم زینب به خانم سیما هم بگید.
بله متوجه شدم. سيما وياي تسمعين؟ اي تقولي احنا حاليا بس اذا ما طول عندنا دلتا اكس دلتا تي 3 نقاط والدلتا اكس 5 نقاط، فاحنا نقدر 3 في 5 15 نقطة. انت وصلت ليش الفكرة هاي زين؟ يقول بين هذني النقاط، يعني اكو هواي نقاط على هذا خط الاعداد غير هذني. تقول ما راح نطلع ذني كلهن، بس هذني النقاط نقطة التقاطع التي ويا الدلتا اكس راح نطلعهن. وصلت الفكرة؟
Miss Sima, do you understand? Very good. Okay. Thus, we have 15 grid points that these points are obtained by using delta x and delta t. Okay? So, it's the break time. We have 15 minutes for the rest, and then we come back to the class. Okay? We have 15 minutes for break, and then come back to the class. Feel fresh.
Yes. Okay. صار عدنان رست. وين كنت؟
وتراي تكمل المحاضرة.
Miss Zainab, Mr. Adnan.
Yes.
Yes.
Delta X and delta T we understand that we have only 15 points for grid or for mesh. Okay, and now we want to compute u respect x. Part B of this question is approximate the ux of xt and also ut at xt by first order forward difference finite difference approximation. Everyone, when we say FD, our purpose is finite difference. This approximation formula, let me find the formula. This formula is the finite difference approximation. This formula is the finite difference approximation for u respect t at xi and tj. Finite difference, only we write FD. FD is abbreviation for finite difference, and this formula is the one of the finite difference approximation and is the first order finite forward finite difference approximation for u respective. It is clear for you about FD. FD means finite difference, and this formula is the finite difference formula for UT. Okay? Okay, yes or no?
اوکی
finite difference، تفاضلات متناهی. ما نقاطمون رو متناهی کردیم. 15 تا نقطه فقط داریم. پس میگیم finite difference، تفاضلات متناهی. Okay. For the for this question, we want to compute first order forward difference finite difference approximation. Means u respect t with I and j is approximated by forward formula u I and j plus 1 minus u I and j over delta t. Okay, I compute for one point, and for the other points you should compute the ut. Let me erase this page. Okay, this page is erased. Okay. For this point, we have u 0 and 0. Okay. And for this point, we have what? For this point, we have what? Please say to me. Are you here? Please say to me about the index of this point for you. U x for the index for x is 1. Okay, ببینید the index for x is 1 and for t is 0, and for this point we have u 1 and 0. Okay, for the next point we have u 2 and 0. Okay, the index for x is 2 and the index for t is 0. For the next point we have u3 until we should
And 0.
write 0 for t. Okay, for this row we have the index for t is 0. For the next point we have u4 and 0, and this is end again, and it is not important for me. The end of x is 0, and we have u4 and 0. Okay,
Okay.
if you attention to this row, for the second index at this row we have only 0, 1 0, 2 0, 3 0, 4 and 4 0. Okay, for the next row, for this point we have u. The index for x is 0 and for t is 1. u 0 and 1. The next point u 1 and 1. Okay, the second index is 1 for all points at this row. For the next point we have u. Index for x is 2 and for t is 1. u 2 and 1. Next point u 3 and 1. For the next point we have u 4 and 1. And the last row, for the first point at the last row, we have u. The index of x again is 0, and the index of t is, we have in the third line for t, and we have u 0 and 2. Next point, u 1 and 2. For next point, we have u 2 and 2. For the next point, we have 3 and 2. And finally, we have u 3 and 3. Okay? We want to use the forward approximation to compute the derivative of all of these points. Okay. For this formula, we have u respect t and I and j is approximate to u I and j plus 1 minus u in I and j over delta t. For example, we want to compute u respect t at 2 and 1. Which point is 2 and 1? This point is the point with x2 and t1. Based on this formula, I should write u2 and 2 minus u2 and 1 over delta t. Okay. What about u at 2 and 2? What about u2 and 2? Please compute u2, 2. U equals to x2 plus 2. Okay? It's okay? U is x2 plus 2. U1 u2 and 1 means u at x2 and t1. Excuse me, x2, I write xt. x2 and t1. We have x2 equals to x2 is 0.1, t1 equal to name to 0.5, and t2 equal to 1. Okay, u21 equal u of x2 and t1 equal to x2 equal to 0.5 and t1 is 0.5. Okay, and u of 0.5 and 0.5 equal, we should put 0.5 for x and for t in the formula of u, and then we have 0.5 over 2 plus 0.5 over 2 order and 0.5 over 2 is 0.25 plus 0.25, and we have 0.5. Okay, it's the value of u at x2 and t1. We need u22 and u21. We compute u21, and then we should compute also u22. Okay, u22 means u of x2 and t2. Okay, equals to u of x2 is 0.5, 0.5, and t2 is 1. U of 0.5 and 1 equal 2. U equal to x2 plus t2. Okay, we have x equal to 0.5 and t is 1, and we have 0.5 power 2 plus 1 power 2 is 1, and we have 1.25. Okay, we compute the value of u21 and u22. Okay, we replace this value at this formula, and we have u22. What about u22? I forget. 1 plus 25. 1 plus 25 minus, what about u to 1? U to 1, I forget, 0.5, yes, okay, it's correct. 0.5 over delta t is 0.5. And then what about the result? What about the result? We should compute we should compute 1.25 minus 0.5 over 0.5, and we have 1.5. This is the approximate of u at this point, at u respect t at x2 and t1. Okay? It is okay?
Okay.
Okay.
What? Let me ask you some question. 1.5. What is 1.5? Is it the value of derivative, value of u? What about 1.5? It's the exact solution of u respect t, is the approximation of ut, is the exact solution of u, is the approximation of u. What about this value? For what? Yes, it's the approximation. For what? For u or for derivative of u? For u? No, for u respect t. For derivative of u. Please attention. ut at x2 and t1, not u. We approximate ut. This is the derivative of u. 1.5 is the approximate of the derivative of u respect t. Okay, this is approximate of the derivative of not u. We compute approximate for u respect t by using u. We use the value of u at 2, 2 and u to 1. We use this value, and by using this formula, this fraction, we compute the approximate for ut, for derivative of u respect t. This is a forward approximate finite difference. Forward approximation finite difference for approximate the u respect t. Okay? This formula is the forward. Why we say this is forward? Because when we use compute u t at 2, 1 for this point, we use the next point. We use u2, 2, not u2 self 2, 0. If we use u2, 0, we say the formula is backward. When we use u2, 2, the next point respect to u2 and 1, we use this formula is the forward formula. Okay? این میگیم یک فرمول پیشرو هست، پسرو نیست. پیشرو یعنی از نقطه بعدیش در محاسبه این فرمول استفاده میشه، نه از نقطه قبلیش. اوکی؟ اوکی. Please compute ut at the point 3 and 1. Please compute ut at 3 and 1 by using forward.
u x3 t1.
Please let me to describe. Please attention to me. We are using this formula ui and j plus 1 minus ui and j over delta t. Please check this diagram. We should compute u respect t at u at the point with the index I and j, and we use u at I and j plus 1. u I j plus 1 minus u I and j over delta t. u at I and j plus 1 minus u at ij over delta t. It's very simple of this formula. u at I and j plus 1 minus u of uij over delta t. Delta t is the distance between 2 points. Okay? This is a simple way to understand this formula. uij plus 1 minus uij over delta t. This is the very simple formula. uij plus 1 minus uij over delta t. Okay? This is the diagram for this formula. And so you compute. Please send to me your solution. 3-1. UT 3-1. Yes. If you send to me your solution, please inform me. Are you finished? Are you done? Please repeat again. The approximate UT at U31. Yes, that is U32 minus U31 over delta. Okay. This is diagram U32 minus U31 over delta T. Third, you write U3 and 1. Can you see? But you should see UT at the UT of 3 and 1, not U. Okay? U3 and 1, UT. We are going to compute UT, not U. U is clear. We have U because we have the formula for U. We are trying to UT. Okay? UT with the indexes 3 and 1. Okay? Not U. خب and you write U3 and 2 minus U3 1 over delta T is okay. U3 and Y is X3 is 0.75 is okay. and x1 is not. What about x1? T1. T0 is 0, okay? T1 is 0.5, not 1. T2 is 1, okay? T1 is 0.5. It's not correct. U32, please, it's better you don't have write U over 3 and 2. You should write U index 3 and 2. Okay, it's equal to U x3 and T2. It is correct. U3 and 2, it's not correct. 3 and 2 should be indexes, not the variable, not the value for U. Okay? U3 and 2, it's not correct. You should write U with the index U3 and 2 is equal U of x3 and T2. It is correct. Okay? Are you understand? Very good. Check your solution to check your correct and not incorrect term that you understand or not understand. What about other students, Miss Zainab? Miss Zainab, do you send to me your solution? Mr. Adnan, do you send to me your solution? Yes or no?
No.
Miss Zainab, where are you? Are you solving?
نه حل نکردم. در خونه‌مو زدم، ببخشید نبودم.
Okay. Thank you from Miss Sima and other students. I solve this part by myself. We should compute UT with the indexes 3 and 2. We draw the diagram for this point, please. Attention. We want to compute UT at the point with the indexes 3 and 1. Okay? By using this diagram, we should use U32 minus U31 over delta T. Okay? Is approximate by U32 minus U31 over delta T. Then we should compute U32 and U31. We go to the above, we go above, and we should compute U31. Let me erase this page. Okay, it's sufficient. For compute U32, we use index 3 and 2 is equal U at x3 and T2. Okay? Cannot see my screen?
عندنا صفحة سيما. خط
Please share
الإنترنت
again.
مالتي ضعيف.
Please share. Can you see this diagram? I repeat again. I have said for compute UT at x3 and 1 at this point. The diagram is U32 minus U31 over delta T. It is a diagram for this formula U32 minus U31 over delta T, okay? And then we should write UT 3 and 2 is approximate by U32 minus U31 over delta T. And should compute U32, U31, and then replace at this fraction. U32 equals U at x3 and t2, and it is equal to U x3 is 0.1 0.75. T2 is 1, okay? So we have U is x2 plus t2, and we have the value of this point, U at this point, is 0.75 over 2 plus 1. And the answer is we should compute 0.75 over 2 plus 1, and we have 1.5625, okay? It is the value of U32. And then you should compute U31. It means U at x3 and t1, okay, equal to x3 is, what about x3? x3 is what? x3 is 0.25. 0.25, and T1 is 0.5, and we should compute 0.75 power 2 plus 0.5 power 2. And what about the solution? What about the answer?
قد الناتج طلعته.
5. Okay. 0.8125. And finally, we should replace these values at our formula, and we have U32 is, what about U32? I forget it. 1.26 and 26 and 26, 25 minus 1.81 25 over delta t is 0.5. And what about the solution of this fraction? 1.5625 minus 0.8125 over 0.5, and the solution is 1.5. Okay? Okay, everybody.
Okay. Yes, yes.
Please attention to me. At home, please compute the value of UT at all of points of this grid. Okay? Please compute a UT at all of points of this grid. Means, please let me erase this page. No, only by using a forward finite difference approximation. I write your exercise. You should compute UT I and J. I and J and UX I and J. UX and UT I and J. For I equal to, I is the index for X, okay? I is used for the indexes for X. And start from 0, 1, 2, 4. Okay, it's okay. And J is the index for T. J is the index for T and start from 0 until what? No, for J we have 2.
2.
T sef T1, T0, it is T0, it is
And
T1, and it is T2, okay? And J is the index for T, and J is 0, 1, and 2, okay? This is the first exercise, and above you can see this exercise. You should approximate the UXXT and also UTXT by first order forward difference finite difference approximation. Okay, I hope that you understand this first forward approximation for UT and UX. This is the first order forward approximation to UT. Okay. Is it okay? Where are you?
اوكي هسه تريد الحل شنو؟
What about finite difference first order approximation respect X? It has discussed the last session, and it is in the book that I'm teaching from that book. Please let me to open this book. You respect X is the topic at the last session, last week. This part الان دارم میارمش. It's the page at the page 21. At the page 21, you can see you respect X and I and N. At this book, use the N and I. No problem. You can say you can use I and J, N and I. This is optional. This is the formula. At this book, use UX, T and X, but I use X and T. No problem, they are optional. This means UX, I with our index, I and J is approximate by U I plus 1 and J minus U I and J over delta X. Okay? The diagram for this formula is I'm trying to draw diagram for this formula. It's I. This point is this point has indexes I and J. Okay. And this point has I plus 1 and J, okay? Is it clear for you? And we use U at this point minus U at the before point over delta X. This is a diagram for this formulation. U I plus 1 J minus U ij over delta X. We should this formula for U respect X at Xi and Tj. For example, I compute one case for this formula. For example, please let me erase this. Okay. Suppose that you want to approximate U respect X, not U respect T. You respect X at 2 and 2. Okay? It means I want U respect X, the derivative of U respect X. Respect X and 2 and 2. What a diagram? The diagram is when we want to compute Ux at U22, we shoot the next point at this row. U2, it is U3 and 1, U22, it's here. It's here. The index of X should be increased. The index of X should be increased forward. The index should be forward. And we use U at 3 and 2. The index of T is constant. Okay? Please attention to me, everybody. For U respect X, the index of T is constant. But the index of X should be increased. U at 3 and 2 minus U at 2 over delta X, not delta T. By delta X, because we are going to compute derivative of U respect X, not respect T. Then we should use delta X. Okay? When we compute respect X, the index of T is constant, and when we want to compute U respect X, the index of X is constant. Okay? We need to compute U3 and 2 and also U2 and 2. Let me to compute U3 and 2. U3 and 2 equals to Ux3 and T2 equals U at 0.75 and 1. What about this solution? Do you have the solution of this computing? 0.75 power 2 plus 1 is 1.5625. Okay? Are you here? And
okay.
for U22 equals to U at X2 and T2. Okay? And equals U at X2. X2 is the third point and is 0.5, and T2 is 1. And we should compute the 0.5 power 2 plus 1 and equals 125. Okay? And now we should replace this value instead of U32 and U22. U32 is 1 minus 1.5625 minus U22 is 1.25. Okay? And over delta X is 0.25. And when we compute this fraction, we can approximate the UX to 2. Okay? the compute of this fraction is for you. Okay, everybody. Please solve this part and send to me your solution until tomorrow noon. And then tomorrow afternoon you send the solution. So okay. شما حلاتون رو تا فردا ظهر برای من بفرستین. منم تا فردا شب حل یعنی جواب ها رو برای شما ارسال میکنم. اوکی؟
اوکی.
For any point you should I write for you. You should UTIJ and UXIJ for I equals 0 to 4 and J equal 0 to 2 for all point. For 15th point of this grid, of this mesh, you should compute your respect T for all points and your respect X for all points. Only by using the forward approximation. At the next
يا
session.
سؤال تريده يا سؤال خانم، هو هذا اي جي؟ لا مو كل النقاط، قاعد 5. قاعد ليش ما حددتش لل4 الاي والجي لل2؟
خانم زینب طالبی برای
همه نقاط میخواین؟
چی؟
همه نقاطی که الان
بله.
آی و جی داریم، همه نقاطی که برای آی و جی، نه فقط همه نقاط تا
نه همین 15 تا نقطه. یعنی فور آی مساویه با 0 1 2 3 4
خودشون متوجهتون همه نقاط. گفتم چجور میشه؟
نه خب من نگاه کن خانم طالب، به بچه‌ها لطفا بگید از این بعد وقتی ما میگیم همه نقاط، منظور همین نقاط گسسته است. با پیوسته ما کاری نداریم. این از این بعد تو کلاس من هر وقت میگم همه نقاط، منظورم همه نقاط گسسته است. ما دیگه با پیوسته کاری نداریم، چون نمیخوایم حل کنیم، که میخوایم تقریب بزنیم. درسته؟ این لطفا بهشون بگید
که مو كل النقاط، كل النقاط اللي موجودات هنا، كل النقاط كم نقطة عندنا؟ 4 في 3 اي 15 نقطة عافية. تريد هي ذني كل واحدة نطلع لي هنا من البداية للنهاية، للظهر الباكر الظهر. اي ال 15 مو الى ان. اي هاي يا باكر تريدين باكر للظهر، تريد الاجوبة مالتها للاكس وللتي اللي هي نفسها اكس اي وجي، بعد ما عندنا اكس تي. صح. اوكي خان باقر.
Okay. I want to familiar you with MATLAB software. Please install the MATLAB on your system, and for next session, not next week, next sessions when we now you are ready for programming, you start programming with MATLAB. Please install MATLAB software on your system. لطفاً برنامه مطلب رو سیستماتون نصب کنید. حالا نه هفته دیگه، وقتی به جایی برسیم که بدونم شما آمادگیشو دارین، حداقل با مطلب درس آشنا شدین، تلاش میکنم به شما مطلب رو هم یاد بدم. این محاسباتی که الان دارین دستی انجام میدین، اون موقع با مطلب انجام میدیم. یعنی مثلا همین مشتق رو با مطلب می‌نویسیم برنامه‌شو. به مطلب دلتا ایکس مشخص می‌کنیم.
ممنون میشیم خانم باقری.
حالا ان شاءالله که برسم. امیدوارم برسم. شما تلاش کنید که با من همراه باشین که حالا برسیم در واقع اینا رو بگیم. لطفاً خانم زینب بهشون بگین که مطلب نصب کنن. بگین حالا نه هفته دیگه، از هفته‌های دیگه ما کم کم مطلب هم شروع میکنیم.
تقول انا راح انصب برنامج مال ماتلاب زين، ومن اسبوع مو الاسبوع الجاي من اللي وراها اعلمكم حتى ليش تكتبون ورقه وقلم، تكتبون بالمطلب وهو يعطيكم الناتج مباشره. اوكي، انا اعلمكم اياه لان لازم تعرفون المطلب. زين هو البرنامج غير دز لنا اياها، شلون نعرف البرنامج؟ خانم باقری خانم باقری
Are you
هستین؟
understand everybody?
خانم باقری شما برنامه مطلبم برام بفرستین که اقلا ما نصب کنیم.
برنامه‌اش
بدونیم.
حجمش خیلی بالا نمیشه فرستاد. شما باید از سایت هایی که میشه دانلود
ما
کرد
ما مثلا
دانلود
اقلا شکلشو بفرستین، شکلشو بدونیم چه شکلی
آیکون
اقلا بفرستین.
من شیر اسکرین میکنم، آیکونش روی سیستم
بله.
ببینید. بذار من اسکرینم شیر کنم.
باشه ان شاء الله.